Today we'll be looking at arithmetic progression. The first question which comes to my mind is, what is a progression? Progression refers to the act of progressing, that is moving from one element to the next element in a systematic manner. A sequence can be termed as progression when there exists a certain relationship between its terms. There are three main types of progressions: arithmetic progression, geometric progression, and the harmonic progression. What is arithmetic progression? A successive progression in which the difference between any two consecutive terms is constant and is independent of the position of the term. Or in other words, we can say the difference between the term and its preceding term is always a constant. If we take any two terms, irrespective of their position, the difference between the term and its preceding term is always a constant. Let's see an example. 1357 is an arithmetic progression. Let's see how the 1357 is an arithmetic progression. The first term in this sequence is 1. The second term is 3. If we take the difference between the second term and the first term, that is 3 minus 1 is equal to 2. If we take the difference between the third term and the second term, 5 minus 3 is equal to 2. If we take the difference between the fourth term and the third term, 7 minus 5 is equal to 2. So we see, irrespective of the position, if we take the difference between the term and its preceding term, if it is constant all throughout the sequence, then we can term it as the arithmetic progression. So 1357 is an arithmetic progression. Minimum, how many terms are required to judge whether a sequence is an arithmetic progression? Suppose if we are given the numbers 1, 3, can we predict the next number? We can't, because we are not mentioned that it is an arithmetic progression. What will be the common difference? With only two terms we can't predict whether the sequence is an arithmetic progression. We need at least 3 terms to predict whether the sequence is an arithmetic progression. If we generalize our arithmetic progression, we consider the first term as A. The common difference, the difference between the term and its preceding term is D. The number of terms is N. Then our progression becomes A plus D, A plus 2D, A plus 3D, up till A plus N minus 1D. This forms an arithmetic progression. The nth term of our AP is A plus N minus 1 into D. Let's see an example. The first term of an AP is 5 and the common difference is 3. Then the 20th term in the progression will be, we have to find the 20th term in our